Good morning to all. Today we will be discussing the fifth chapter, that is surface chemistry. As the name suggests, surface chemistry, this chapter will be dealing with the surface phenomenon that is called adsorption. The term absorption will be almost familiar to you. Absorption can be explained with the help of a sponge dipped in water. When a sponge is dipped in water, the water molecules will penetrate inside the sponge. That is, the bulk of the sponge will be filled with water. Each and every void space of the sponge will be filled with water. So absorption is a bulk phenomenon because the water molecules are penetrating deep inside the bulk of the sponge. But uh, our chapter is dealing with adsorption. Adsorption is dealing with something different. We can explain that with the help of a tester. When we clean a blackboard using a tester, what happens? The chalk dust particles are getting accumulated on the surface of the tester. The chalk powder is not penetrating into the bulk of the tester, but it is retained on the surface. It gets accumulated on the surface of the tester. So this adsorption is a surface phenomenon, whereby the particles are getting adsorbed or retained on the surface of a particular substance. So it's a surface phenomenon. On the other hand, absorption is a bulk phenomenon because the water molecules are entering into the bulk of the substance. So as a final word, we can say adsorption is a surface phenomenon and absorption is a bulk phenomenon. So right now we will be dealing with the definition for adsorption. The accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. So the definition says like this: the accumulation of a molecular species at the surface rather than the bulk of a solid or liquid is termed as adsorption. So with the help of the chalk powder and tester, you can see that the chalk powder is getting accumulated only on the surface, and that's why it's called adsorption. So there are two key terms that are involved in this particular process. One is adsorbate and the other is adsorbent. So this definition for adsorbate and adsorbent is very important. So we'll define that. The molecular species of substance which gets concentrated or accumulates at the surface is called adsorbate. So what is adsorbate? The molecular species, the molecular species of substance that get concentrated or accumulate at the surface is termed as adsorbate, and the material on which adsorption takes place is called adsorbent. So this is the definition for adsorbate and adsorbent. So if you take the example of chalk powder and tester, chalk powder is a substance that is getting accumulated on the tester. So chalk powder is the adsorbate, and this chalk powder is getting accumulated on the tester. So tester is the adsorbent. Okay, now I think the definition is clear. The molecular species which is getting concentrated is called adsorbate. So hence the chalk powder is getting accumulated, it's adsorbate, and this chalk powder is getting accumulated on the tester. So it's the adsorbent. So next topic is adsorption in action. That is, 4 examples are given here where the process of adsorption is involved. The first one is if gas like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide is taken in a closed vessel containing powdered charcoal, it is observed that the pressure of the gas in the enclosed vessel decreases. The gas molecules concentrate at the surface of the charcoal. That is, the gases are adsorbed at the surface. So in this experiment, what they are doing is like some gases like oxygen, hydrogen, carbon monoxide, etc. introduced into a closed vessel, and we are introducing powdered charcoal into that particular vessel. So after 1 or 2 hours, what is observed is that the pressure inside the vessel decreases. Actually, what is pressure? Pressure means that when the gas molecules are filled in the container, the gas molecules will be it is in constant rapid motion. It will be colliding with each other and with the walls of the container, and this collision will actually ultimately result in pressure of the gas. When activated charcoal is introduced and after 1 or 2 hours, what is observed is that this particular pressure inside the chamber decreases. Why? Because these molecules were adsorbed by the charcoal, and due to this adsorption, the collisions has been drastically reduced, and thereby the pressure of the entire system is reduced. That is one application of adsorption. The second one is in a solution of an organic dye, say methylene blue, when animal charcoal is added and the solution is shaken well, it is observed that the filtrate turns colorless. The molecules of the dye thus accumulate on the surface of charcoal and are adsorbed. So it's the same experiment. An organic dye, specifically it is methylene blue, and it is taken in a particular vessel, and animal charcoal is also introduced into it. Animal charcoal means the charcoal that is made up of the bones of animals. It's an organic dye. It is specific, It is methylene blue. It is introduced in a vessel, and into that vessel, animal charcoal is introduced. And once it is shaken well, it is observed that the filtrate, the color of the solution turns colorless. Why? Because the coloring part, the dye that is responsible for giving color, the methylene blue dye, that particular dye was it got absorbed on the surface of animal charcoal. So the coloring matter is now absorbed by the charcoal. So no longer the solution can exhibit the property or that particular color. That is the second example for adsorption. The third one, aqueous solution of raw sugar, when passed over the beds of animal charcoal, becomes colorless as the coloring substances are absorbed by the charcoal. So aqueous solution of raw sugar. So we know sugar is made from sugarcane. How is it made? First, we'll extract the sugarcane juice, and we'll remove the water content by evaporating, and then finally you'll get the sugar. So basically, in this step, the color of sugarcane juice, it's somewhat the brownish color. So when you make the sugar out of it, it will definitely look like it won't be very pure sugar that is we are getting in the home. Right now what we are getting is the white colored sugar, but actually sugar is made up of sugarcane juice, which will be having a brownish tint or color. So actually what we do is that the aqueous solution of raw sugar. So once the raw sugar is in aqueous form, it is passed over the beds of animal charcoal. The animal charcoal will be laid on the floor, and this particular aqueous solution of sugar will be passed over the bed with the help of a conveyor belt or something like that. Then the coloring matter will be absorbed by the charcoal or animal charcoal, and hence the sugar becomes colorless. So it is white in color. The last one, the air becomes dry in the presence of silica gel because the water molecules get absorbed at the surface of the gel. This is another interesting example. That is, whenever you buy an electrical appliance, just like computer or something, inside the package you can see a silica gel package. Or if you buy a leather shoe, you can see a silica gel inside that. So what is the purpose of it? Have you ever thought of it? See, when while transporting, there is definitely a chance of water moisture to enter in this particular package. If water moisture is there, if it is an electrical appliance, definitely there it might result in a short circuit or something like that. What if it is a leather shoe? If it comes in contact with water, there is the fungus attack would be there. So in order to avoid all this, whenever you are transporting something like electrical appliance or something made of leather, they used to keep or place a silica gel inside that. Why? Because the silica gel has got the property of absorbing the moisture content. So the moisture water vapor inside that particular package will be absorbed by the silica gel, and hence the particular electrical appliance or the leather shoe will be protected from the damage caused by water vapor or moisture. Okay, these are the 4 examples. One more point is there. What is desorption? See, desorption. So please read the definition. It is clear from the above examples that solid surface can hold the gas or liquid molecules by virtue of adsorption. The process of removing the adsorbed substance from the surface on which it is adsorbed is called desorption. So what is desorption? Desorption is the opposite of adsorption. Adsorption means the process whereby the substance get accumulated on the surface, and desorption is the opposite, like the process whereby the substance get detached from the surface. So in this example, it is very clear that the green colored molecules are getting accumulated on the black colored adsorbent. So the green color atoms or molecules are the adsorbate. The black colored substance on which it is getting accumulated is called the adsorbent. So hence it is clear that what is adsorbate and what is adsorbent. So one more example we'll deal, that is the gas molecules are getting accumulated on charcoal. You can see the black colored charcoal at the bottom of the vessel, and the gaseous molecules are present everywhere, and after some time you can see that the molecules are getting accumulated on the surface of the adsorbent, that is charcoal. So now we will deal what is desorption, the reverse process of this. The substance that has been absorbed on the adsorbent is now removed from the adsorbent. This is called desorption. Our next topic is distinction between adsorption and absorption. So it's a 2-mark question, differentiate between adsorption and absorption. So first we will go through the paragraph. In adsorption, the substance is concentrated only in the surface and does not penetrate through the surface to the bulk of the adsorbent. While in absorption, the substance is uniformly distributed throughout the bulk of the salt. So it's very clear for you. For example, when a chalk stick is dipped into ink, the surface retains the color of the ink due to adsorption of the colored molecules, while the solvent of the ink gets deeper into the stick due to absorption. The example of chalk and ink we'll study in detail with the help of video. Right now we'll go for the next point. The distinction can be made between adsorption and absorption by taking an example of water vapor. Water vapors are absorbed by anhydrous calcium chloride but adsorbed by silica gel. What does this mean? Water vapors are adsorbed by, see, this point. Water vapors are adsorbed by anhydrous calcium chloride. What do you mean by anhydrous calcium chloride? Calcium chloride molecules that are not having water content. Anhydrous means like devoid of water. So anhydrous calcium chloride, or simply the NaCl, the common salt that you're using in your home, if we expose that to room temperature or air, if we keep it in open air, you can see that after 2 or 3 days, like it has become deliquescent. Deliquescent means it has become watery. Why? Because it will absorb the water moisture content in the air and hence it will become deliquescent. On the other hand, the silica gel will be absorbing. In case of silica gel, we already discussed, adsorption is taking place. In silica gel, the water molecules will be it will be accumulated on the surface of silica gel. So that's the difference between adsorption and absorption. Now, with the help of a chalk piece and ink, we have to study the difference between adsorption and absorption in detail. So we'll be moving to the video. In this video, we'll be mainly focusing on the difference between adsorption and absorption. See, adsorption is a surface phenomenon whereby the atoms are getting accumulated only on the surface of that adsorbent. Okay, but absorption is different. In absorption, you can see the green colored atoms are penetrating deep inside the bulk of the adsorbent. So that is the difference between adsorption and absorption. Adsorption is a surface phenomenon. On the other hand, absorption is a bulk phenomenon. That is the difference between adsorption and absorption. Next, we will deal with an example of chalk dipped in ink. Here, ink is actually a solution that is composed of a solvent and a solute. The solvent is it's mainly a solvent like hexane, and the solute is the dye that is responsible for giving color. So ink is a mixture of a solvent plus dye. So when you dip the chalk in the ink, see, this is the after effect of that. You can see the outer part of the chalk is the color of the dye is retained on the outer part. So the dye is now only on the surface of the chalk. So dye has been adsorbed. But what about the solvent? You can see the solvent has penetrated inside. You can see the color change. So since the solvent has penetrated inside, that is absorption. Next, we have to study a term called sorption, S-O-R-P-T-I-O-N, sorption. See, to define sorption, the definition is given like this. Both adsorption and absorption can take place simultaneously. The term sorption is used to describe both the processes. So sorption means the process whereby adsorption and absorption take place simultaneously. That is sorption. Next, we have to study the mechanism of adsorption. So first, we'll deal with the theory and later we'll explain the mechanism with the help of a video. So the paragraph is like this. Adsorption arises due to the fact that surface particles of the adsorbent are not in the same environment as the particle inside the bulk. Inside the adsorbent, all forces acting between the particles are mutually balanced, but on the surface, particles are not surrounded by atoms or molecules of the kind on all sides, and hence they possess unbalanced or residual attractive forces. These forces of the adsorbent are responsible for the attracting the adsorbate particles on its surface. The extent of adsorption increases with increase in surface area per unit mass of the adsorbent at a given temperature and pressure. In this video, we will be explaining the mechanism of adsorption. So this is the molecular arrangement of an adsorbent. And here we will be considering two atoms. One atom will be, we will consider that like in the bulk, an atom in the bulk of the adsorbent. And another atom would be like at the surface. So two atoms we'll be considering. One is in the bulk and the other, that is marked in blue color, is on the surface of the adsorbent. Now, what is the difference between them? The green color atom will experience attractive forces from atoms are present everywhere around it. Everywhere around it, atoms are present. So it will be experiencing attractive force from molecules everywhere around it. But what about the surface atom, the atom situated on the surface? It will be only experiencing attractive force from atoms below and on the surface. So that is the difference. No force of attraction is held from the top of the particular atom into consideration. So there will be always a driving force that is attracting the particular atom towards or inside the bulk of the adsorbent. So once again, I'll explain. We'll consider two atoms. One is green color that is inside the bulk of the adsorbent, and the other is a blue colored atom that is on the surface of the adsorbent. The atom that is green, which is inside the bulk, will be experiencing attractive forces from everywhere around it because that particular atom is surrounded by atoms everywhere. So the net effect is the same. On the other hand, the atom on the surface, that is the blue colored atom, will be experiencing only attractive force from like the atoms on the surface and down. So always there will be a driving force that is attracting the atoms towards the down into the adsorbent bulk, and it won't be experiencing any sort of attraction from the top of that. So always there is an attractive force that is holding the atoms towards the bulk of the adsorbent. So this ultimately results in the adsorption action. So there will be an inward force experienced on the surface of the adsorbent. This particular inward force is responsible for the adsorption action. Our next topic is type of adsorption. So mainly there are two types of adsorption. One is physisorption and other is chemisorption. As the name suggests, physisorption means it will be some physical forces that will be holding the adsorbate and adsorbent together. So we know that in the process of adsorption, the adsorbent and the adsorbate are in very close in contact with each other. In physisorption, the physical forces like van der Waals forces, example hydrogen bonding, then dipole-dipole forces. The physical forces will be responsible for holding the adsorbate and adsorbent together. That is physisorption. On the other hand, chemisorption. In the name itself, everything is there. Chemical bonds will be there connected between adsorbent and adsorbate. The adsorbate and adsorbent will be connected by chemical bonds, and these chemical bonds are responsible for holding the adsorbent and adsorbate together. So it's again a 3-mark question. Differentiate between chemisorption and physisorption. So we'll be dealing that in detail. First, we'll watch a video depicting the difference between physisorption and chemisorption, and then we will point out the difference between chemisorption and physisorption. So now we'll be discussing the difference between physisorption and chemisorption. In physisorption, it is the weak physical forces like van der Waals forces that are holding the adsorbate and adsorbent together. As an example, if you rub a scale on your hair and place it near a small piece of paper, we can say that the small piece of paper are being attracted to the scale. It is simply the electrostatic force of attraction that is holding the paper and the scale together. One will be negatively charged and the other is positively charged. So there will be an attractive force between the unlike charges. Similar in this case, the adsorbate are the purple colored molecule, it will be a hydrogen molecule, and it is being absorbed on the white colored atom, that is the adsorbent. So here, let the adsorbate be positively charged, let it be positively charged, and let the adsorbent be negatively charged. So definitely there will be a force of attraction between the positive end and the negative end, and this will be responsible for holding the adsorbate and adsorbent together. We'll deal with one more example. See, in this example, on the surface of platinum, hydrogen molecules are being adsorbed. We can see that it is just physical forces that are holding, the van der Waals forces that are holding the hydrogen molecules on the surface of platinum. And one more thing is that this physisorption, like it is possible only in the case of low temperature. Now we will study what is chemical adsorption or chemisorption. Chemical adsorption or chemisorption is defined as a phenomenon that occurs when gas molecules or atoms are held to the surface of a solid by chemical bonds. So this is chemisorption. So see, in the case of physisorption, there is a van der Waals force acting between the adsorbate and adsorbent, and this is possible only in the circumstances of low temperature. Only if low temperature prevails, the physisorption will take place. If the temperature is raised, the physisorption will no more exist, and the force of attraction between the adsorbate and adsorbent will no longer be existing. So this is physisorption case. But in chemical adsorption or chemisorption, it will be strong chemical bonds that are holding the adsorbate and adsorbent together. See, in chemisorption, strong chemical bonds are there between the hydrogen atoms and the adsorbent, and that is why they are like held strongly towards the adsorbent even at high temperature. So this chemical adsorption mainly occurs due to one is ionic bonding and covalent bonding. So chemical bonds can be either ionic bond or covalent bond. Now we will be discussing the difference between phase absorption and chemisorption. It's a 3-mark question, differentiate between phase absorption and chemisorption. The first difference is phase absorption arises because of van der Waals forces and chemisorption is a result of chemical bond formation. So we have already discussed this. Second point is that phase absorption is not highly specific in nature. On the other hand, chemisorption is highly specific in nature. Being specific in nature means, in case of chemisorption, if oxygen has to be adsorbed on a metal surface, like metal oxide has to be formed. Similarly, if hydrogen has to be attached to a metal, the corresponding metal hydrate has to be formed. So there is a specific condition for the adsorption to take place. But in the phase absorption, there is no specific conditions for that. It just need to be an opposite poles. One should be positive and next should be negative, so that the weak van der Waals forces can act between the two. So that is meant by specificity. Phase absorption is not specific, but the chemisorption is highly specific. Third one, it is reversible nature. Phase absorption is reversible in nature, but chemisorption is irreversible. For example, phase absorption. See, we are cleaning a blackboard with a duster. Okay, so the dust particles are accumulated on the duster, and it is simply the weak van der Waals force that is existing between the chalk powder and the duster, and no chemical bonds are formed. That is phase absorption. But if you heat the duster on a wall, we can say that the dust particles will get removed. That means it is reversible in nature, not chemisorption. If two molecules A and B are connected or adsorbed with the help of chemical bonds, like it is difficult to break. That is, it is irreversible. So that is chemisorption, phase absorption. The fourth difference is phase absorption depends upon the nature of the gas. More liquefiable gas are adsorbed more readily. Once again, phase absorption depends on the nature of the gas. More liquefiable gas are adsorbed readily. That means phase absorption is highly dependent upon the nature of the gas. Highly liquefiable gas will be readily absorbed. What about chemisorption? Chemisorption also depends upon the nature of the gas. Gases which can react with the adsorbent show chemisorption. So chemisorption, we know it is a resultant of chemical bonds. So a particular gas that is able to form a bond between the adsorbent, they can be adsorbed by the process of chemisorption. That is the fourth one. Fifth point is phase absorption. The enthalpy of adsorption is low. In the case of phase absorption, it is almost 20 to 40 kilojoules. The energy involved in the phase absorption is less. But on the other hand, chemisorption, the enthalpy of adsorption is high. The energy involved in this transaction is 80 to 240 kilojoules per mole. That is a high value compared to phase absorption. So in phase absorption, the enthalpy of adsorption is less, but in chemisorption, the enthalpy of adsorption is more. That was the fifth point. Now the sixth point, about the phase absorption. The sixth point is low temperature is favorable for adsorption. It decreases with increase in temperature. So we had already discussed that phase absorption is highly favorable only in low conditions, low temperature conditions. If the temperature is raised, like the extent of phase absorption is drastically reduced. So the sixth point is low temperature is favorable for phase absorption. The phase absorption decreases with increase in temperature. But on the other hand, for chemisorption, high temperature is favorable for adsorption. It increases with increase in temperature. Chemisorption, the extent of chemisorption will increase with temperature. It is directly related to temperature. On the other hand, low temperature is favored for phase absorption. If temperature is increased, the extent of phase absorption is decreased. Seventh point is no appreciable activation energy is needed for phase absorption. See, we are cleaning the blackboard with the tester, so we need not supply any kind of energy for this adsorption process. So no appreciable means no energy has to be supplied. But for chemisorption, high activation energy is needed sometime. We know for chemical bond formation in the lab and all, we used to supply heat energy for a particular reaction to take place. So in some cases, high activation energy has to be supplied. That is the seventh. Eighth one, it depends on the surface area. Phase absorption depends on the surface area. It increases with increase in surface area. It's very simple concept, right? The duster, If the duster has got a bigger surface area, the more will be the extent of adsorption of the chalk dust particles. If the duster is of having a small surface area, the ability to adsorb will be less. What about chemisorption? It also depends on the surface area. It too increases with increase in surface area. Then also the concept is simple. More surface area means more atoms will be present on surface of the adsorbent. More atoms means more chemical bonds can be formed, and hence the extent of adsorption can be increased. See the ninth point. Physisorption results into multimolecular layers of adsorbent surface under high pressure. Once again, it results into multimolecular layers. So physisorption is multimolecular, but on the other hand, chemisorption is unimolecular. See the same example, duster and the chalk powder. See, think that we are cleaning the blackboard with a fresh duster. So once we clean the blackboard, a layer of chalk powder is present on the duster. So again we are using it again. After some time we are again cleaning the blackboard with the same duster. So the second layer will be accumulated on the duster. So multi-layers is formed in the case of adsorption. So more and more layers are formed, the extent of adsorption is being decreased, even though multi-layers are formed in the case of physisorption. But in the chemisorption, see, A and B are joined with the help of a chemical bond. So only a monolayer can be formed. So think that A is adsorbent and B is adsorbate. So a chemical bond is formed between A and B. So a monolayer is formed. Again, a multi-layer, a layer beyond that B, it is not possible. So physisorption is physisorption is multi-layered and chemisorption is monolayered. So these are the differences. So out of these 9 points, anyway, you should remember 5. So this is a definite 3-mark question. Differentiate between chemisorption and physisorption. The next topic is absorption isotherm. The variation in the amount of gas absorbed by the adsorbent with pressure at a constant temperature can be expressed by means of a curve termed as absorption isotherm. So absorption isotherm is basically a graph which represents the variation of extent of adsorption with respect to pressure at a constant temperature. The Freudenlitz absorption isotherm. Freudenlitz in 1909 gave an empirical relationship between quantity of gas absorbed by unit mass of a solid adsorbent and pressure at a particular temperature. The relationship can be expressed by the following equation. And the equation is x by m is equal to Kp raised to 1 by m, where x is the mass of the gas absorbed and m is the mass of the adsorbent, p is the pressure, and k and n are constants which depends upon the nature of the adsorbent and gas at a particular temperature. So Freudenlitz absorption isotherm is basically a graph. It shows the relationship between extent of adsorption with respect to pressure. So x by m, the term x by m can be used to represent the extent of adsorption. Why? Because x is the amount of gas absorbed. Think that the charcoal is absorbing some gases on the surface. So the amount of gas absorbed on the charcoal, that is what is called x, the amount of gas absorbed. And the mass of the adsorbent, the mass of the charcoal is represented by the symbol m. So x by m will represent the extent of absorption. How much gas is absorbed by the charcoal? So it is related to K into P raised to 1 by n, where P is the pressure which is maintained in that particular environment. K and N are constants. So these are constants K and N they depends upon the nature of the adsorbent and the gas. So this is the relationship between x by m and Kp raised to 1 by n. That is also called Freudenlitz absorption isotherm. In this video, we will be discussing the absorption isotherm in detail. So in this video, you can see that a vessel is maintained at a particular temperature and pressure, and it consists of charcoal and gas molecules around it. So due to adsorption, the gas molecules will be accumulating on the surface of charcoal. So this is the idea behind adsorption. And the extent of adsorption can be expressed with the help of the term x by m, where x is the mass of the adsorbate and m is the mass of the adsorbent, that is of charcoal. And now we will be plotting a graph between amount of gas absorbed versus pressure. So pressure will be taken on the x-axis and amount of gas absorbed, that is x by m, will be taken on the y-axis. Now if we plot a graph at a constant temperature, we can see that we will be getting a curved line like this. So that curve will be representing the variation of extent of gas absorbed with respect to pressure. And this relationship was proposed by Friedrich in 1909. And we know the relationship is x by m is equal to kp raised to 1 by n. So he found that the extent of absorption, that is x by m, is proportional to p, where x is the amount of gas absorbed and m is the mass of the absorbent. This particular extent of absorption is directly related to pressure in that chamber. So after removing the proportional design, we'll get x by m is equal to k p raised to 1 by n, where k and n are constants which are related with the nature of the gas. So x by m, the value x by m represents the amount of gas absorbed by a unit mass of the absorbent. N and k are constants. So you can see the graph here that is named as Friedrich absorption isotherm. It depicts the variation of amount of gas absorbed with respect to pressure. We can say that at a particular pressure Ps, like the amount of gas absorbed has attained a maximum value. From that, like it's a straight line. That means it has become saturated. See, x by m at a particular pressure Ps, like the amount of gas absorbed x by m has attained a particular value. If you further increase the pressure, there is no more change. You can see it has already attained an equilibrium. So that point is called the saturation state. If you apply more pressure, there won't be any change in the amount of gas absorbed. So it will remain the same. That is a particular pressure is called saturation state, where no more adsorption will take place. The next topic is adsorption from solution phase. Solid can adsorb solids from solution also. So in the previous topic, we are discussing adsorption of gas by a solid, that is charcoal. So here we will be discussing adsorption of a solution by the solid charcoal. See, when a solution of acetic acid in water is shaken with charcoal, part of the acid is absorbed by the charcoal and the concentration of the acid decreases in the solution. Similarly, the litmus solution when shaken with charcoal becomes colorless. So from all these observations, the following conclusion has been made. There are 4 conclusions made. The first one is extent of adsorption decreases with increase in temperature. The second one is the extent of adsorption increases with increase in surface area of the adsorbent. Third one is the extent of adsorption depends on the concentration of the solute in the solution. The fourth point is the extent of adsorption depends upon the nature of the adsorbent and the adsorbate. So these are the 4 observations. So basically what you can observe here is the precise mechanism of the adsorption from the solution is not known. Friedrich's equation approximately describes the behavior. So what it says is that in the case of adsorption of solution by a solid, the same equation can be applied. That is x by m is equal to kc raised to 1 by m. So what is the difference here? In the previous topic, we are discussing adsorption of gas by a solid. So when we are dealing with gas, it was x by m equal to k p raised to 1 by m. So when dealing with gas, that is pressure taken into consideration. And in the case of solution, we will be using concentration instead of pressure. That's the only difference. So what is the equation here? X by m equal to kc raised to 1 by m. And what does that mean? The extent of adsorption, that is x by m, where x is the mass of the solute and m is the mass of the adsorbent. And this value will be, the extent of adsorption will be equal to kc raised to 1 by n, where c is the concentration of the solution. The next topic is applications of adsorption. The phenomenon of adsorption finds a number of applications. The important ones are listed here. The first one is production of high vacuum. The remaining trace of air can be adsorbed by charcoal from a vessel evacuated by a vacuum pump to give a very high vacuum. So with the help of a vacuum pump, like vacuum can be created, but still there will be traces of air inside that particular environment. That traces can be removed with the help of a charcoal, and these traces of air will be adsorbed by the charcoal, which eventually results in perfect vacuum conditions. The second one is gas mask. So in gas mask, adsorption is used. Gas mask, a device which consists of activated charcoal or a mixture of adsorbents, is usually used for breathing in coal mines to adsorb poisonous gases. So usually in coal mines, it's situated very deep inside the earth, and there will be insufficient amount of oxygen. So carbon will react with less amount of oxygen from carbon monoxide. So we already know carbon monoxide is a poisonous gas. If you inhale carbon monoxide, it can eventually even result in death because carbon monoxide will combine with hemoglobin and form carboxyhemoglobin, and your cells will be supplied with carboxyhemoglobin, and this carbon monoxide can result in cell damage. So, if you wear a gas mask which has got activated charcoal inside it, when the air is being inhaled through the gas mask, that mask will absorb the poisonous gases like carbon monoxide. Third one is control of humidity. Silica and aluminum gels are used as adsorbents for removing moisture and controlling humidity. So that is what I explained previously. So whenever you buy an electrical appliance or a leather shoe or something like that, you can see a silica gel or aluminum gel placed inside there. That is simply to absorb the moisture content inside the package. It will take 2 or 3 days for the transportation of the package, and in between, if it comes in contact with water moisture content, like if the electrical appliance, if it is coming in contact with water or vapor, something like that, there will be a chance for short circuit. Like the substance like leather will be having a fungus attack if the presence of moisture is there. So if you place a silica gel or aluminum gel there, the humidity will be absorbed and it will be free of humidity. The fourth point is removal of coloring matter from solutions. Animal charcoal removes color of solutions by absorbing colored impurities. So we have discussed decolorization of sugar cane juice. So sugar, it should basically be yellow in color or brown in color, but once the aqueous solution of sugar is passed over the bed of animal charcoal, the coloring matter is absorbed, and that is why the sugar is pure white in color. The fifth point is heterogeneous catalysis. Adsorption of reactants on solid surface of the catalyst increases the rate of the reaction. There are many gaseous reactions of industrial importance involving solid catalyst, manufacture of ammonia using iron catalyst, manufacture of sulfuric acid by contact process, and use finely divided nickel and hydrogenation of oils are excellent examples of heterogeneous catalysis. So first we will explain what is heterogeneous catalysis. You are already familiar what is catalyst. Catalyst is a substance that will speed up a chemical reaction. Okay. Heterogeneous catalysis means the catalyst and the reactants will be in different phase. For example, in the manufacture of ammonia, finely divided iron is the catalyst, and this finely divided iron is a solid form. But the reactants, nitrogen and oxygen, they are in the gaseous state. So heterogeneous catalysis means the reactants and the catalyst should be in different phase. See, nitrogen and hydrogen are in the gaseous phase. On the other hand, the catalyst, that is the iron, is in the solid state. So that is heterogeneous catalysis. So this catalysis work with the help of adsorption. The principle behind this catalysis process is adsorption. On the surface of catalyst, the reactants are getting adsorbed, and the catalyst serve as a platform for the reaction between the reactants to occur. So that is catalysis. On the surface of the catalyst, the reactants get adsorbed and they will react on the surface catalyst, and the products are formed. So that is the principle behind catalysis. The sixth point is separation of inert gases. Due to the difference in degree of adsorption of gases by charcoal, the mixture of noble gas can be separated by adsorption on coconut charcoal at different temperatures. See, different noble gases will be adsorbed in a different extent. So based on the degree of adsorption, the mixture of noble gases can be separated into its individual constituents. The seventh point is in curing diseases. A number of drugs are used to kill germs by getting adsorbed on them. So simply explained. The eighth point is flotation process. The low-grade sulfide ores is concentrated by separating it from silica and other earthy matter by this method using pine oil and frothing agent that we already had discussed in metallurgy chapter. Okay. The ninth point is adsorption indicators. Surfaces of certain precipitates such as silver halides have the property of absorbing some dyes like eosin, fluorescein, etc., and thereby producing a characteristic color at the end point. So they help in determining the end point in adsorption. So they serve as adsorption indicators. The last one is chromatographic analysis. Chromatography, there are many types of chromatography like thin layer chromatography, paper chromatography, column chromatography, etc., which we have already studied in the first PUC. So chromatographic analysis based on the phenomenon of adsorption finds numerous applications in analytical and industrial field. So chromatography mainly deals with separation of two or more components. So this is based on differential adsorption. See, in a column chromatography, the column will be filled with silica gel and a solvent will be introduced to the top. And the solvent is the mobile phase and the silica gel is the stationary phase. So this particular mechanism of chromatography deals the principle behind that is adsorption. If a compound is more adsorbed by the silica gel, it won't be the movement will be restricted due to the polarity. So more adsorbed, which is more adsorbed by the silica gel, the movement of that particular compound will be less, and which is less adsorbed will be moving fast along with the solvent. So based on this differential adsorption, the two compounds can be separated. So these are the areas where the adsorption principle has been utilized.